Hi guys and girls, good morning. Sorry I'm not there with you. I am in self-isolation as it says on the front screen there. Not because I'm poorly, but because I'm old. So as I've said, Mrs McKenzie does science from self-isolation, and there's a little cover note at the bottom that says, what could possibly go wrong? Quite clearly, quite a lot. This is the 7th attempt to get this right. Various things have conspired against me. So hopefully this one will be better than some of the previous attempts. So what I wanted to cover today was question 9.5, the one that we didn't get around to doing on Monday. So don't have the paper at home, don't have anything like that with me. So literally I've gone online, found the question. Hopefully this will make sense. So the question, I've distilled out all the information, and this is a really good top tip for exams as well, is to highlight the information that's really important. So this is the results of a titration. Titration between sulfuric acid and potassium hydroxide. We don't know the concentration of potassium hydroxide, we just know the fixed volume. But we do know the concentration of sulfuric acid, and we do know the volume that was used to neutralise. We know the molar reacting ratios because we've got the balanced symbol equation. And the question is actually asking us to calculate the concentration of potassium hydroxide in moles per decimetre cubed and grams per decimetre cubed. So let's have a look and see if we can get this sorted. So first things first, you'll notice that all of the volumes in the question are in centimetres cubed. Now to get from centimetres cubed to decimetres cubed, you have to divide by 1000. Now, the volume is your first step. So 15.5 centimetres cubed of sulfuric acid divided by 1000 gives us 0.0155 decimetres cubed of sulfuric acid. That's your first step. You then need to calculate the moles of sulfuric acid. So to do that, moles equals concentration times volume. That's one of your formulae you need to learn. So in this case, moles equals 0.5, because we've got 0.5 moles per decimetre cubed, times 0.0155 decimetres cubed, which gives us a total of 0.00775 moles. That's the first point. We now know how many moles of sulfuric acid were in our reaction. We need to work out the moles of KOH now, potassium hydroxide. So we know from the balanced symbol equation that 2 potassium hydroxides react with 1 sulfuric acid. So therefore our ratio is 2 to 1. We've got 0.00775 of sulfuric acid. So it's 2 lots of that, which gives us 0.0155 moles KOH in the reaction. Okay, I'm just going to change page because I'll give you a couple of seconds just to write it down, then I'm going to change page and move on to the second part. Okay, part 2. You can always stop and rewind if you need to. The second part we need to work out is our concentration of KOH. So this is the main part of the question. Now we've already written down on the previous page the concentration calculation. So concentration, by rearranging, is equal to moles divided by volume. It's just a rearrangement of the equation. So we know that we have 0.0155 moles in 25 centimetres cubed. And we need to know how much we've got in 1 decimetre cubed. So we do 0.0155 divided by 25 and then times it by 1000. And that gives us 0.62 mole per decimetre cubed. That is your first answer. Okay, This is your moles per decimetre cube concentration. Now, it also asks you for the grams per decimetre cubed. A lot of you gave this a go, but didn't get very far with it. So just to finish this little bit off, moles equals mass over mR. We know that in our equation, in our solution, we've got 0.62 moles. You can ignore that little bit at the moment because it's only the number of moles we're looking at. So 0.62 is equal to question mark over the MR. MR of potassium hydroxide is 39 for the potassium, 16 for the oxygen and 1 for the hydrogen. So that's 56. Okay. I'm just going to try and move this slightly. So therefore, 0.62 divided by 56 is our, start again, 0.62 times 56 is equal to our mass. So therefore our mass is 34.7 grams. So the concentration in grams per decimetre cubed is 34.7 grams per decimetre cubed. That is your second answer. Hope that's made sense. If not, ping me an email. I'm at home. I will be on my computer most of the day, so just ping me an email. There's also some other stuff on your Show My Homework entry that you can find. Have a great day, guys.